Hello, everybody, and welcome to the third Thursday Inventors Gathering. This is the one for March 2025, and we got a number of people here. As we always do, we welcome comments. We try to make this a live experience, but the video you're about to see and this whole meeting will be on YouTube after the fact. Um, and now I'd like to begin my talk, but I'd like to welcome the audience to interrupt me with any questions if they have any, although I may not be able to see your faces. What I'd like to talk today is about applications free of shared persistence, which can be very powerful, and how GitHub Pages in particular makes them free of charge. This is a technique which is underused. It's particularly valuable for beginners, but it's really a surprisingly large number of web applications can be built in this way. Public Invention is a US 501(c)(3) public charity that could use your donations to prove to the IRS that we're a public charity supported by the public, like yourself. Our motto is invent in the public for the public. Everything we do is fiercely open source, including all the examples that I'm going to be showing you today. So there's a little bit of terminology involved now. Sometimes people call something no backend or serverless, and that does not quite mean the same thing we're talking about today. What they mean by those things is that the persistence layer or the back end of the programming system or the website that you're developing is very easy to deploy in the cloud. That's not what we're talking about today. We're talking about literally having no persistence, which is shared. And the shared is a very important point that I'll talk about in a minute. So shared persistence means storing something that can be seen by someone else at a later time. You can persist things that you can see over a long period of time. So most applications need a small amount of persistence, but not necessarily shared um, uh, persistence. So often these things are called calculators, which are an example, but they can be very, very powerful. So over the last 10 years, Public Invention has written a number of these calculators, and I'm gonna show these. Some of these can be extremely powerful. I'm gonna show them as examples of how this technique can be used in a very powerful way. All of these, of course, are open source code, which is available at the repos that you see here, so you can examine and copy the code and play with it if you want. So I'd like first to show you an example that I call color block font. I still think this is a good idea. I had this idea and created it 35 years ago. The idea is to replace the little black glyphs that you see that represent the Roman alphabet, which we've been using, some of us, for 2,200 years in the West, and with the ability to make letters made out of color. And so I'm going to go to that right now and show you an example. So this is a calculator that I made, and it shows the system that I'm talking about. I just take all of the letters of the English alphabet, which is very close to the Roman alphabet, and I map them to little color patterns. And for capitals, I use slightly larger letters. And then I can use this as a way to represent text, which hopefully would be easier to read and slightly smaller if someone were to take the time to learn to read it. When I was in graduate school, I almost could read it as fast as I can read English. I can't do that now. Of course, this is my favorite poem, Ozymandias, and it produces what I consider to be a very attractive display that represents the same thing there. Now, this has not really been tested, but what we're talking about today is building a calculator. So here is a calculator that keeps no shared persistence, and I can just type what I used to think was really cool when I was 13. I can say Rob is cool. And when I was a boy, that was thrilling. And this little pattern of color over here is Rob is cool. So you'll notice that the letter O, the lowercase o, occurs 3 times in that pattern after the capital R, and it's two little cyan blocks on top of each other. So this whole system was designed so that you would scan your eyes along the median line of these two blocks, and that you would in that way be able to read quickly. Now, you might ask, what's the point of this invention? Well, for a long time, producing things in color was quite difficult for human beings to do. It was quite expensive to print or paint or draw in color, and it was hard to make color last forever on stone, for example, if it's exposed to the weather. But now it's just as cheap to make something colorful as it is black and white. And so why, if alphabets developed today, if we had never developed these black and white shaped letters, why wouldn't we develop them in color? Now, what practical purpose does that have? Well, if we could put twice as much text in the same space on our screens, it would be as if our computer screens all got twice as big. And that's actually quite important because studies have shown that, in particular, computer programmers are more productive when they have more real estate on their screen. That is, they can show more text at one time on their screen. Okay. Now, in terms of being a calculator, the interesting thing here is that this costs nothing to deploy. It's not just cheap. It literally costs nothing because it's implemented with what is called GitHub Pages, a service provided by GitHub as a utility for repositories which use an open source license, which are public repositories. Now, this is the basic 3-tier architecture for database-backed websites. And this, 25 years ago, this was quite important and perhaps not obvious. Okay, it's still very important. This is still the way things are built, although people don't necessarily talk about it this way. And of course, all computer science is really based on the idea of abstracting things and making them simpler so that we can make complex things without our brains being overwhelmed by the complexity of them. So abstractly, a 3-tiered architecture consists of a presentation layer. Presentation means the way it is presented to a human being. And then what's sometimes called a business logic layer, or just a logic layer, or an application layer. And that's normally where the rules of what you are doing live. And then often beneath that, there's a persistence layer, which we think of as a database. So for example, in an accounting application, the persistence layer is whatever stores the amount that's in the accounts. Very important. Can't have accounting if you don't store the things that are in the account. The business logic layer is what enforces the abstract idea of a transaction. And that is that if you take X dollars out of one account, it has to go into another account if you're using double entry bookkeeping, right? That's a rule that's absolutely enforced by bookkeeping systems implemented on a computer. But then the presentation layer decides, well, if they ask to see the chart of accounts, how many accounts are we going to put on one page? How big is the font going to be? Or is it going to be presented in English or in Spanish, for example? Okay. Now, those layers have not changed, but the typical implementation in 2025 is different than it was in 2000. Okay. Now, the presentation layer is quite often done in a browser, not always, sometimes it's in an app. But the nice thing about a browser is that it has zero deployment cost. You just click on a URL. You don't even have to download anything. You don't have to put an app on your computer. And it provides a certain amount of security because when you go to a website, normally, unless there's a terrible bug, it can't, for example, read other files that are on your computer. It's in a sandbox. Okay, so it's a very convenient way to deploy things, which has almost zero deployment cost. And almost everything Public Invention does is browser based. Now, it used to be this middle layer. What you did is you co-located a server. So you literally bought a rack mount server and you went to some place, usually like a warehouse in the business district of town, not the retail district, but where the industrial parks are, right? And you would take it in and you'd, meet some nerdy guy there, and you'd bolt it into the wall, plug the power in. You owned that server and you paid $50 a month to co-locate that server in that building. Today, almost no one does that. What we do is we rent the same space from Amazon in the form of Amazon Web Services, or Microsoft in the form of Azure, or Heroku, and there dozen others. Those are among the most popular. Anyway, somewhere there is a computer that computes something. That's how the business rules are enforced. But you also often use persistence, because when you leave the website, for many applications, but not all, you want something to remain behind which is persistent and visible to other people. So, for example, you could use a bookkeeping system only for yourself. That could be quite useful, but often a bookkeeping system is shared between multiple people. So you can't keep it entirely to yourself if you're attempting to share it. And then you need a shared back-end persistent store. Okay, now I want to show you another example so that you guys can kind of think about this. Okay, this is one of the first things I did. This is a program, and now it's going to be a little more powerful than the color block font one. This is a program that uses kind of halfway sophisticated graphics to show a three-dimensional shape of the design of electromagnetic coils, okay, which is actually a fairly difficult problem. The problem here is when you have a bobbin here and that has a certain diameter, a coil width, and a bobbin length, and you wind it with magnet wire, that pretty purple kind of copper colored wire, because it has a clear insulation. You can see the copper inside it, to make a motor or a magnet or any kind of thing. There are various reasons you make a coil. You have to design it very carefully, and in particular, you often want to choose the wire thickness, which we call the American wire gauge. That's one way of describing it. And you also have to specify the voltage, the internal resistance of the wire, and certain other aspects of it. And then you can get these fairly powerful three-dimensional renderings that really are only done by GitHub pages. The fact is, my own browser is spending most of the computer cycles to render this. And as you can see here, it's actually quite complicated what the best choice is if you're trying to maximize this height right here. Okay. And what that height is in this case is a number of ampere turns, which is a measure of magnetomotive force. So if under these constraints of a 12-volt system that has I think I have a maximum amperage here, the maximum magnetomotive force that I could wind on this bobbin would be to choose a wire gauge of about 18, American wire gauge 18, and to make the coil width no more than 10 millimeters. Okay, and it might be surprising. You might say, well, why not make it ever bigger? Well, turns out if you make it ever bigger, it actually gets weaker. So you don't want to make it too thin. You don't want to make it too thick. Okay, and when you design a coil, the heat is actually quite important as well, because the bobbin or the wires in it will melt. And so at the same time, you want to maximize the ampere turns, but you want to minimize the wattage inside the coil, or you'll have to do something crazy like immerse it in water or something like that. So anyway, it's not super important, but it's a fairly complicated thing to do. But it requires no back-end persistence. You just change whatever's on the screen and you compute it. And so you can make a beautiful three-dimensional interactive graphics program that's purely a calculator, but there's absolutely no reason to make it anything more than a calculator. Okay. Now, one of the things that makes this possible is GitHub pages. and of course there are competing ways of doing this, but GitHub Pages is, in my opinion, the simplest and easiest to use and the best way to do it, because it's completely free of charge if you're hosting it on a public repo. GitHub Pages pays the small amount of computation necessary to serve those pages, because most of the computation is done in JavaScript on your browser, on your own computer. There's no persistence built into that model. Now, you can add persistence by adding AWS, Azure, Firebase, variety of systems in the backend. But if you don't need shared persistence, it doesn't matter. So why not do it? And it's just as simple as uploading index.html, and I'll show you an example of that. So this is an abstract example of a calculator that doesn't require shared persistence. So you have the same abstract presentation layer and business logic layer, which allow you to separate your code in a pleasant way, but you don't need a back-end persistence layer. Now, you do need a little bit of persistence in the sense that you have to memorize things, if only on the page while the page is up on the screen. And sometimes this is called session variables. I prefer to call them page variables because I don't really use a session, but it's just the amount of memory that's live on the page right now while it's being rendered. You also can have cookies. Now, cookies are small, limited to 4 kilobytes, pieces of information which are stored in the user's browser. So if Christina came to a website and Rob came to a website, it might remember the last time we were there as a timestamp, but it wouldn't store it on the website. It would store it on our respective browsers. And the next time we came back to the website, it would say, browser, please give me the cookie associated with my domain so that I can see the last time they were there and tailor my message or marketing to when the last time they were there. Now, implicit in the model of the browser is that Rob's not allowed to see anyone else's cookie, and no one else is allowed to see Rob's cookies. Okay, and that is a very important aspect of security. If I were able to see all of someone else's cookies, I would have access to things that I'm not supposed to have. Okay, cookies work great. They are not a security risk, but you can't put too much persistence inside them. However, there's a thing called browser storage or browser local storage or local storage, and you can put up to 5 to 10 megabytes of data in that. So if you needed to, you could store a great deal more information, up to 5 megabytes, in the user's browser and still not require shared persistence, as long as no one else has to see that. So let's say I wanted to make a painting program and I paint a pretty picture. As long as it's 5 megabytes, it can be stored on my own browser, as long as I don't expect somebody else to see it. If I expect somebody else to see it, I need to put it in shared persistence, because when my browser is no longer attached, someone else's browser can't see it. It's on a physically different computer and there's no way to get to it from the internet. So GitHub Pages makes all of that pretty easy. Now I want to show you something that Christina and I worked on with a very good young programmer named Prajwal Shah, who implemented this all in a summer. And it shows how you can do something without back-end persistence, but still accomplish some of the things that you want to accomplish. So this is, once again, a calculator here. You can see it's just a website. It's implemented at the public Invention GitHub pages, and I can add an entry here. So I'm going to say, let me give, who's the first? I'm going to give Audrey 30 shares here. 30 shares, that's paltry. I'm going to give her 3,000 shares. So I add this, and you'll notice that the percentage ownership has been recalculated, and in this piece of JSON, Audrey now has 3,000 shares. Okay, Now, what is the purpose of this? I believe this is actually a kind of important thing that people don't know about, because I've been involved with several startups, and you'd just be surprised how often people create startups and they say, okay, we'll split this evenly. But then let's say Melanie joins the team. Does Melanie get a third, or does she get some fraction of the half? And it's never negotiated. People say things, they don't write it down, and then there are lawsuits and terrible problems later because nobody keeps track of what they agreed to. This solves this problem because it allows you to create like a miniature nano startup. You can create a little bitty joint stock company without any, you don't have to register anything, you don't have to create a legal computation, you don't have to, create a corporation, but you can still keep track in a very consistent public way where everybody can see it, what percentage shares everybody owns. Okay, and this is actually a very important function. I don't expect people to realize it, but it's really important. And it doesn't have to be for startups that are for money. It could be like, let's say we're going to clean up a park, right? And we want to keep track of how many hours each person has worked cleaning up the park. Okay, so in this case, let's say Prajwal, did 10% of the cleanup, and Rob did 18% of the cleanup, and Audrey did 32% of the cleanup. We might never make any money from that, but then we might go out to pizza and say, well, Audrey's the best, so we'll pay for her pizza, or something that's not exceptionally valuable, but it's still valuable in the context here, and it doesn't cost anything to keep track of, really, if it could be just as light as, say, insert entry here. Okay. Now, this is an example where you do want this to be shared persistence, right? If I refresh this page, it's gone. Audrey's contribution has just been wiped out, and it goes back to where we were. Prajwal is now up to 16%. So let me put this back for Audrey. I give her 3,000 shares, and all of this is instantly recomputed. Okay. If we wanted to store this, we've got a piece of JSON that we could check into GitHub. And all we'd have to do is use the built-in functions of GitHub to load this in there, and we would have permanently remembered it. So we're not using shared persistence on this page, but we're making shared persistence quite easy. And we did all of that without ever paying anything to GitHub or to anybody else. So it's an extremely lightweight way to build an application. Okay, now I'm going to show you another thing, and I want to first show you the GitHub to show you how it works. So many of you, of course, will know this, but not everyone. This site is GitHub. It's at github.com. You can register at GitHub. I'm not signed in right now because this is totally public. All of you, if you want, you can go to this. I'll put this in the chat. You can go to this repo, it's called, and a repo is a version controlled persistent store, usually used for computer programs, but not always. It can be used for designs, art, text, books, poetry, all kinds of things. Okay, this is actually one of my favorite, one of the things I'm most proud of in the last 10 years is the work that I did here that came out of the Public Invention Mathathon, which I ran with my friend David Jeschke, who sadly passed away in December. I went to his funeral recently, and I noticed something extraordinary, which I'll show you in a minute. But he didn't want to help me with the paper very much, so I wrote the paper, but he helped me observe it. So you'll notice here there's a bunch of stuff, mostly related to papers that I've written. There's a folder for JavaScript right here. And this is most of these things are free JavaScript that you get off the internet for doing graphical work. Some of them are not. This one, segment helix math, Notice it's published under the GNU public license. Like everything we do, it's open source. This is math code that I wrote to actually do what I'm showing you, okay? So even though it's in JavaScript and it runs in the browser and it does some linear algebra and a few other little fancy schmancy things, it's not a big deal, and the browser is plenty powerful to render it. So really the only file that you need to use GitHub Pages here is this one called index.html. And it just renders index.html. It loads the JavaScript. Here's an example of JavaScript being loaded. These are examples of JavaScript files being loaded. And this is really just a standard HTML file that has things like input buttons and sliders, which you're about to see, and text in this case. But there's nothing very fancy about it. Okay. Now in the settings, you can't see the settings right now because I'm not logged in. Anyone in the world can do this. Anyone can come to this website and see this. Okay. Now, it's not obvious what this is until I start moving it and give you visual parallax. This is a helix made out of a repeated shape, which is conjoined with other repeated shapes in exactly the same way. And the magical thing, which was described by Professor Eric Lord about 10 years ago, but he didn't prove it or do any math on it. So I call it Lord's hypothesis. We proved Lord's hypothesis. And that is that no matter how you change this shape, as I'm doing now with this slider interactively in real time, this remains a helix. So if I tell you, you see this prismatic shape could be part of something else. If I had if I put in the corner a mass, a pile of 100 blocks of wood, but they were all cut the same way and they had marks on the face saying how the faces could be conjoined. If you conjoin them the same way every time, it will always be a helix. Okay. And that is perhaps not obvious. Okay. Now, what we've done that was never done before is we can also tell you what the radius of the helix is and what the travel of the helix is. That is how far it is between circulating all the way around the helix to get back to itself. We can compute some other things like the axis direction, the tightness, the pitch, etc. Okay. So that's perhaps marginally interesting, but some mathematicians study things like this. This is a tetrahelix. That is, it is made of tetrahedra. Okay, this one happens to be spiky, but there are ways to change it into this shape so that they're conjoined. This is the famous Burdick-Coxeter tetrahelix, named after Coxeter was the famous Canadian mathematician HMX Coxeter, who first described mathematically the formula that describes its shape. That is the closed form expression that describes its shape. Well, because we had this math, we were able to produce a complete zoo of different kind of helices here, which are often quite interesting in their shape. And so these are using the Platonic solids consisting of tetrahelix, a cube, octahedron, dodecahedron, and icosahedron. Those are like the dice you use in playing fantasy role-playing games. And we were able to show that there are, in fact, only 120 of them, but those 120, many of them are isomorphic. So there are actually only 28 unique such helices. So this is, in my opinion, kind of interesting. And having created this, I can actually change these values. It will no longer be exactly a face-to-face match if I change this slider, but I can tighten it up. And although it self-intersects, so you couldn't do this physically, I can go through this point I once heard someone describe that as the cosmic G spot. And then you can come back over here on the other side. And the radius and all this stuff is computed. So going back to my talk, if I haven't crashed my browser, which is possible. Sometimes this takes. Let me stop sharing. Sometimes that it does consume some things in your browser. It's not supposed to be able to do that. Normally, I'm a little bit prejudiced. I call this the Microsoft maneuver where you have to kill something, but this is not, I can't blame this on Microsoft. This is a Mac. Okay. So I just have one more thing to show you, which is not one of the things I'm most proud of. This was done with my friend Eric Goff. This is meant to be a number line. And so what we were trying to do is to make a tool that a teacher could put on a website anywhere they wanted to, and they could scroll. And so the idea here is this is a number line with the top being the stuff way to the left and the bottom being stuff way to the right. And in the middle is the stuff that you're focusing on. And you can pan to the left, pan to the right, and you can also zoom in. And if you zoom in, of course, it gets smaller and you can continue to zoom until you see things. Now, the little lines that there are rational numbers generated in a particular way. But you can also imagine, putting irrationals on there like square roots, prime numbers, and so forth. So the idea was to make a pedagogical tool that was a visual display of a number line, which could show very rich data sets. But could all be programmed here, wouldn't cost anything, and wouldn't require a backend server. Okay, so we're almost done with my talk here. So in conclusion, the keep it simple, silly principle is very important. Don't use a heavyweight tool if you can accomplish it with a lightweight tool. The YAGNI principle is also important. YAGNI stands for you ain't gonna need it, which means many people will begin a project and they'll say, well, I have to have a login, right? Because I'm gonna have to have security and I've got to have a backend database because eventually I'm gonna want to share these things. But no, you ain't gonna need it. Now, sometimes your users show you that you do in fact need it, but don't build something until it's absolutely necessary. One of my mentors, Kent Beck, liked to say, I don't know if he invented it, always do the simplest thing that can possibly work. Now, you can't be idiot simple, right? I mean, you can do a lot of things that there's no way they could possibly work. You don't have to waste time on that. But, you want to do the simplest thing that has a chance of working. And in fact, a project that many people here are familiar with, the Global Distributed Tracking project, has made, I think, a lot of mileage out of not requiring authentication because it's the simplest thing that may possibly work. So that ends my talk now, and I'm happy to entertain questions. I have not been looking at the messages, so if anyone sent me a message, I may have missed it.
No questions so far.
Okay.
I actually have a question though.
Yes.
So hearing your presentation, it made me think of the open source project that's mostly housed on GitHub, also known as Ruby on the Rails. And And essentially it's a development environment for, I think, web applications. I'm not super familiar. I've just heard a few talks about Ruby. I haven't coded anything in it. But what's your perspective on web application? Like, how has it changed because of obviously tools like GitHub and what it enables with one, the team environment and the what is it called? There's a word, a technical term for it in computer science where it's the track of managing like commits or what you commit versus like version control. So features like that are highly utilized in computer science and programming development. And I think that Ruby on the Rails is a newer language in software and programming that helps to prevent, I think it's called redundancy. And so I don't know if you're really familiar with this coding language, but what would be the reasoning, or I guess the benefit of using GitHub to house this open source platform for web app frameworks and development that you could think of?
Okay, well, there are a lot of questions rolled up inside there.
Yeah.
So that's a little complicated. So I have written things in Ruby on Rails in the past. Um, I don't particularly like it, but every language has certain advantages and disadvantages. Uh, GitHub allowed you to make sophisticated web apps using, I think, Ruby, but it still didn't allow you to have a persistence layer. Like there was no persistence built into the model, right? But
Mhm.
you could build a powerful thing. The actual system they used was called Jekyll. And maybe it still supports Jekyll for that, but you don't need it because you can do most of the same things with JavaScript and JavaScript libraries, which are free and easy to use. So I'd rather not express an opinion about Ruby itself because it's not relevant to this talk. So is there a question related to, you were talking about commitment, right?
Or
Um,
committing. Like when you make commits, web commits on GitHub, you're committing part of the changes and then adding a note. So when you use GitHub in this web, like a team environment, that's typically the advantage of having it in industry and open source. So how does that benefit with, I guess, web applications or different coding projects that you would, I guess, rely on GitHub to store versus doing it on other modes?
okay, well, that's an interesting theoretical question. Okay, so first of all, yes, GitHub has atomic commits, right? You code is either committed or it's not committed. It's never half committed, right?
Right.
And that is the so-called ACID principle of atomic, consistent, independent, and durable of a transactional database. So it is not a relational database, but it is like a transactional database. Typically, you use relational databases for financial applications, for example, where it's very important that, if Megan is transferring money to Rob, it's not half transferred, right? It's either all transferred or it's not transferred. And that's the principle of atomicity, right? It can't be divided. Um,
Mhm.
okay. Now, in a sense, you could use GitHub as a database, right? But as a database, it's a very slowly changing database because human beings type code and enter it into the database. But that happens at the speed of human beings, which are very slow, compared to
Mhm.
other things, right? So, for example, you could easily write a game where the state of your character as it like moved from room to room and pulled out a magic wand and zapped a dragon or something was stored as a GitHub commit in somewhere. You could use it as a store for that. It's not designed for that. You probably shouldn't do that, but in theory, you could do that. Okay. Now, many applications need a backend data store. For a long time, everyone used relational databases. Now people use NoSQL databases often, not always. Um, and that offers the same kind of commitment. NoSQL databases tend to be based on what are called blobs or binary large objects, where the meaning of it is not interpreted in the persistence layer, but is interpreted in the business logic layer. So that what you're sticking in the database doesn't know what it is. It's just a bunch of bytes. It's going to give it back to you when you ask for it, and the business logic layer is going to operate on it.
Yep.
Okay. Now, I don't know if I've answered your question.
We were talking about commits. So what would be the benefit of commits in GitHub and using Bash, I guess, and Git to, I guess, develop web frameworks and web applications? Keep in mind, I'm a novice, if even that. Like my background's in biomed, so I don't have a lot of fundamentals when it comes to programming, I guess, tools
Okay.
and stuff.
Well, suppose you were building an application that was going to run.
Mhm.
I would recommend you use Git and GitHub. Git is a fundamental tool. GitHub uses Git to store the code as it is committed as you write it. So normally what a programmer does is they're like, I want to make some improvement, or I have to fix a bug. Work on it, type, test, work, type, test, it's good. Then you commit it. It means you push it into the repo where your team members, perhaps spread across the whole world, can more or less instantly see it. Okay? That's a commit. Now, if let's say you're making a game though, right? And let's say it's a shared game like World of Warcraft or something like that, right? You know, if my little character moves from one room to another and Megan is playing in a different part of the planet, but her character moves into the same room with me, they have to see each other. They have to know, they have to share a space there. So they can't be separate. There has to be a shared space. So that can be done with commitments to a database, but that's not the same as the GitHub code database.
Okay.
And that database would normally be implemented with something like MongoDB or Redis or Firebase or SQL or some AWS store, Azure Blob Store, something like that. Okay.
Right.
Everyone needs commits.
Mhm.
You really can't do any shared work without a notion of commit, whether it's formal or informal. But the GitHub commit is designed for code, not for general data.
I see. And I, sorry not to ask so many redundant questions, but you say it's not for data. Do you think that its reliance on other systems for databases like SQL, non-SQL, or I can't remember the other ones you listed, but will be a future feature development, you think? Or do you think that they could easily just keep relying on these other tools that can be for free or for profit, and it will still be probably highly used and without limitations?
I don't see any value in GitHub integrating a general purpose database into its model. If you want to do that, you can do it at low cost, not free, but at very, very low cost by using Azure, AWS, Heroku. There are probably others that I don't know about. If at that point you would just switch to one of those hosting services. The GitHub pages, I do not work for GitHub, but they got a lot of value out of implementing it because it lets you make a beautiful website at no cost, which is associated with the code that you're developing. So in all of those examples that I showed, part of what I'm doing is I'm showing off the code that I made, right? Like the segmented helix, the point is the math, but the visual thing shows that the math works. It's almost a visual proof that the math is correct because it always produces a helix. That's valuable to make, it makes my code more valuable that I have a little lightweight decoration that's live. It's an interactive decoration of my code. But GitHub doesn't particularly want to do the same things that Amazon Web Services does, for example.
Right. No, that makes sense. I appreciate it.
And just to throw out there, like all good rules, they're made to be broken. People use GitHub for large databases as well. It has support for something called blob data, which is just giant chunks of data that that it treats it more like a database. If you look at how like Hugging Face uses Git style technologies for hosting massive gigabyte sized LLM models, it's slightly different. And the way I use Git is I use it so I can keep concurrency across multiple computers. So even though if I'm not contributing with anybody else, I can have a computer, I can have the same code on my laptop as my desktop. And as long as it's committed to Git, I can make sure I always have the same code base no matter where I'm at. That's why I use it.
Right. And
Mhm.
that's the example of shared persistence. You want shared persistence, not necessarily with another human being, but between two different computers to see the same shared view of something.
I noticed on your example for
Cap.
the nano cap table that to enter an entry, you have to have a valid GitHub token. So maybe you talk a little bit about like what a valid GitHub token and how GitHub uses a token-based system for like micro authentication for apps and such.
Oh yeah, I'd almost forgotten about that. I mean, you don't have to use that, but I think correct me if I'm wrong here. You can use that if you want to use the button on the page to actually store it in GitHub. So what Prajwal and Christina and I were trying to do was to make a repo that other people could copy as a template. So they could literally begin with this as a template to start their enterprise, right? At no cost, you can duplicate a public repo, right? So, let's say Megan and Victoria and I decide to create a company tonight. We're going to make an AI company that tells you how to fry squid eyeballs or something like that, right? So, we might say, well, I'll do the programming, so I should get 40% of the code. And Victoria, the money, the billions of dollars we're going to make. And Victoria says, well, I'll do the marketing, so I should get 30%. And Megan said, well, I'll do the taxes, so I should get 30%, right? And so we say, okay, we put those in, and then Lawrence says, I want to be part of it, and we say, okay, well, Lawrence, because you're late to the game by 10 minutes, we're only going to give you 5%. But where does that 5% come from? Well, if you do it as shares, it just magically contracts everybody else and he gets 5%, right? Um, Now, where do you actually store that? Well, if you just copied a GitHub repo and you all have downloaded GitHub tokens, then on the page, you have the right to use the GitHub API to store something in that GitHub repo. Otherwise, you can't do any persistence. Okay. But it's not that different than if you had a password to some other database like Amazon Web Service or Firebase that was in some other place. You could also store it in some other place. It's just convenient to keep it at GitHub. Why? Because GitHub provides version control. Okay. So everyone, presumably everyone who's part of the enterprise can go back in time and the uh, look at the file. Okay, so what is the file? In this case, it's captable.json. Okay, that's literally the file. This literally defines, like we would say, who owns what portion of this enterprise, right? Well, Prajwal owns 1,000 shares. Rob owns 1,700 shares. Okay, but that number of shares can just increase, if we all agree to it. Now, using the um, history function that's built into GitHub, we can see for this cap table that certain things might have changed. Okay, so this was the latest change. Okay, and it's actually showing us, oh, well, that's not a change to cap table. I'm sorry. So here we're seeing cap table, and we changed it to, someone actually changed that part of the file. Okay, this file here, that's different than index.html. So if we were using this to really record these things, we could have some dispute, right? So after some time, Christina could say, wait a second, why do I only have 1,500 shares? I thought I was supposed to have 2,000 shares. Well, we could go back in time if we chose to and say, well, we can show you exactly when everyone got their shares, and we can see there is no 2,000 here. Okay. That might seem super simple, but it's incredibly important for people who are starting businesses because they screw it up all the damn time. I've seen it happen twice in businesses that ended up being worth millions of dollars. Okay. Now, this model of code where you can see differences and you can see changes is not what a relational database provides. It's a exceptionally valuable model for things that are large, human readable, and slowly changing. Not a great model for other things that are changing super rapidly because it would be really hard to interpret any meaning for it. Okay. In a way, these commits, when you see this history, are like transactions in a double entry bookkeeping system, except instead of modifying accounts, you're modifying text files.
I tried to give myself like 99.999 billion shares, and on my side, it gave me 100% ownership of everything. But I wasn't able to commit it because I did not have the right token.
There you go. We
So,
didn't give you that many shares, Lawrence.
and even if I had done so, I would have a record of my nefarious actions.
You would, and we would have a chance to dispute it if we did that. I mean, there are other ways of solving this problem, but this would just be a very convenient way to solve a problem that costs almost nothing, that haunts many enterprises when they first start up. People can't remember what was promised to whom. And, the beauty of this is, although no one has used it as far as I know, and we haven't written a paper about it, unfortunately, someone should, it's usable today. In my opinion, there's nothing stopping anybody from using it except the fact that they don't know about it, right? Do we have any other questions? Mr. Manone, you seem to be new. Do you have any comments or questions?
No, I don't think so. Thanks for the question, but I think it's interesting to hear the applications of these
Okay,
serverless pages in GitHub. Yeah.
cool. Thank you for joining. Okay. Well, if we have no other questions, I'm gonna wait just a second to see if anyone does, and then I'll stop the recording. And usually after I stop the recording, people have a lot of questions. Okay, well, thank you everybody for being here. Remember, public invention, our goal is to make open source hardware inventions. You've seen some software inventions tonight. We meet here every third Thursday. It's free of charge. Our goal is to make humanitarian inventions that really save the world. We're a public charity. We could use your public support. Thank you, and I'll stop the recording.